Hey guys, welcome to Transistor Therapy. In this video, we'll have a look at the various parts of the Arduino IDE software and get started with the coding in the Arduino. Okay, first up, the Arduino IDE software is mainly used to write the code for your sample project, compile them, and dump them onto the board. You can download this IDE software from their official website, for which the link is given in the description below. After installing the Arduino IDE software, this is how it looks like, and you've just got to know a couple of things before you actually start to code with the Arduino, such as File. Under File, you have many options such as New to create a new sketch, Open to open any recent sketches, and Close the current sketch, and Save the current sketch. And under Sketch, you have Verify/compile, which is used to verify your code for any syntax or logical errors, and Compile to compile your code, and Upload. This upload option dumps your code into the hardware. And under Tools, you have got to know two important things, which is under the board, you have to select your model of the Arduino which you have bought. In this case, my board is Arduino Uno, so I'm just going to select it here. And the other important thing is the port. When you connect your Arduino to your personal computer, this port option will be enabled. When you click this port option, it will show you some communication ports or COM port numbers, where it will show you various number of ports, and one of which the Arduino will be connected to it. We also have many shortcuts which will come in handy while coding, such as this shortcut stands for verifying your code, and this shortcut stands for uploading your code or dumping them onto your board, and this one stands for creating a new sketch, and this one is to open any recent sketches, and this one is to save your current sketch. So let's now look at the structure of an Arduino program. So basically the structure consists of two main functions, which are the setup function and the loop function. So what is this setup and loop function, one may ask? So the setup function is called when the sketch is started first, and we basically use this setup function to initialize the variables, pin modes, and start using libraries, etc., whether you're using an LCD or an LED, etc., or a keyboard. And the setup function will run only once, which is either after a power up or when the Arduino board is reset. So once we're finished with the setup function, we enter the loop function. So what is loop function? Well, the loop function is used, as its name suggests, to loop consecutively, allowing your program to change and respond. Well, we mainly use it to control the Arduino board and write the main program in here. Now let's get on with the data types which are compatible with the Arduino. Number 1, char. A data type named char stores a character value and takes up to 1 byte. A variable declared as char can store numbers, alphabets, and some symbols. The characters are stored inside the compiler as numbers, which are basically the ASCII codes of the values. For example, we have two character variables, ch1 and ch2, where ch1 stores a single character value, whereas ch2 stores multiple characters. Here, single characters are enclosed within a single quotes, whereas multiple characters are enclosed within double quotes. And the multiple characters enclosed within double quotes are also known as strings. Number 2, unsigned char. Well, unsigned char is an unsigned data type which occupies the same space as the char, which is 1 byte of memory. The unsigned char data type encodes the numbers from 0 to 255. For example, let us consider an unsigned char data type variable initialized to the value 88 So here 88 is the ASCII equivalent to the block letter X. Hence, the unsigned char variable ch1 will be initialized to character block letter X by the compiler. Number 3. Byte. A variable declared as byte is an unsigned 8-bit number ranging from 0 to 255. For example, let us consider a variable b declared as byte initialized to a value 19. Hence, the compiler sets the variable's value to 19. Number 4. Int. The integers are considered as primary data type for number storage. The int size varies from one board to another, and since we are using Arduino Uno R3, the size of the int in this board is of 2 byte or a 16-bit value and successfully yields the range of -2 power 15 to +2 power 15 minus 1. For example, let us consider a value val which is declared as a type int and initialized to a value 100. Hence, the compiler stores the value 100 inside the variable val. Number 5. Unsigned int. The unsigned integers are same as the normal integers in the way that they store 2 byte values. Well, instead of storing negative numbers, the unsigned integer always stores positive numbers, yielding a range of 0 to 2 power 16 minus 1. Well, for example here, the unsigned int count variable stores the 89 as its value, which is always positive. Number 6. Long. The data type long is of 4 bytes of memory space and its range is from -2 power 32 to +2 power 32 minus 1. For example, consider the value val declared as a data type long with the value 10200. The unsigned long is also of 4 bytes which stores only positive values and its range is from 0 to +2 power 32 minus 1. For example, consider an unsigned long variable val of value 10200. The long and unsigned long are the data types, which is basically the extended sized version of the integers. Number 7. Word. The data type word is of 2 bytes of memory space in case of the Arduino Uno R3, and its size may vary from one board to another. For example, the variable w declared as a word initialized to a value 55. The compiler will store this 55 value inside the w. Number 8. Float. The floating point data type number is a number which has a decimal point. The floating point numbers are often used to approximate the analog and continuous values because they have greater resolution than the integers and they take up 4 bytes of memory space. For example, consider a variable speed declared as a floating point number which is initialized to a value 22.56. Number 9. Double. The size of the double data type is 4 bytes of memory space in the Arduino Uno R3, which is basically the same as the floating point number, but it varies with the other Arduino boards up to 8 bytes. For example, let us consider a variable distance declared as a double data type with the value 320.4. Hence, the compiler will set that value as double and put it into the variable distance. And that's it for today, guys. So in this video we learned how to use the Arduino IDE software and started with the programming basics by learning the data types which are compatible with the Arduino. Hope you have all understood properly, and if you have any doubts in this video, please put it on the comment section below. And if you like this video, please press the like button and don't forget to share and subscribe to get the latest updates on more of the tutorial videos. Adios everyone.